Our speakers today are Randy Estabrook, QCC Executive Director, Wayne Hintz, QCP Program Manager, and Greg Parham, QCP Inspections Manager. Welcome, Randy, Wayne, and Greg. Thank you so much for being here with us today. I will pass the floor over to you.
Thanks, Cameron. This is Wayne Hintz, and most of the information today is going to be presented to you by Randy and Greg. But before they start, I'm just going to take a couple of minutes to briefly review what relative humidity is, since that's the central topic here today. Relative humidity is expressed as a percentage of the total amount of water vapor that a unit of air is capable of supporting at any particular temperature. And beyond that total capacity, the air becomes saturated with the vapor, and the vapor begins to precipitate out in the form of a liquid. And if you're outside, that might be rain or dew, or if you're in an indoor space, that precipitation might be condensation on a window, or it might be condensation on a wood wall panel, which of course is not good, and it's something a lot of us have probably seen. And the rule of thumb is that the lower the air temperature, the less water vapor it is capable of supporting, because the air molecules are moving more slowly than they would at higher temperatures. And another way of stating that is what you see in this diagram. You've got two equal units of air in terms of volume. The one on the left, let's say, is at 65 degrees. The one on the right is at 85 degrees. Let's say they are both at 50% relative humidity, meaning they contain half the total amount of water vapor that the air in each unit is capable of supporting at its respective temperature. So if the vapor in each cube could be condensed and contained in a beaker as liquid water, there would be less water in the beaker representing the lower air temperature on the left, even though both units of air are at 50% relative humidity. And of course, the amount of humidity in a unit of air is not only dependent on the temperature, it also depends on the availability of water in the environment. As we all know, for example, Phoenix and Washington, D.C. might both be 90 degrees on any given day, but because Arizona is basically a desert, as its name implies, it will have low humidity relative to D.C., which is virtually surrounded by water. And in the case of an indoor space, humidifiers and dehumidifiers make water vapor more or less available to the air in the building as a means of stabilizing humidity levels in the building, even if the building's temperatures might be programmed to vary. So once we introduce wood into an environment with humidity, the wood acts basically like a sponge. It's called, that property is called hydroscopic, meaning that wood can absorb water and retain water vapor from its environment. Of course, with wood, it's a little more complicated than that, because it will also release humidity into the air depending on whether the temperature is going up or down. And, you know, everybody expects there to be some variation of humidity, but as Randy and Greg are about to tell you, it's when that exchange of water vapor becomes very extreme and you get the swelling and shrinking associated with that issues can develop on an architectural woodwork project. So Randy will now give you the details.
Thank you all for dialing in today. I think most people in this industry are very familiar with the problems associated with moisture, with humidity, relative humidity. I can remember many years ago, maybe the first project where I became intimately aware of how critical this issue is. I think we were doing the Chevron Government Affairs Office in Washington, D.C., and we had installed some, I believe, anti-gray wall panels on the project. And it seemed like in about a week's time, a 4-foot panel had shrunk 1/4 of an inch in width. to me, that was amazing. And the contractor, of course, said, well, what's wrong with your panel? I mean, it was wider than that the other day, and now it's smaller than that. So what's causing this? And I think my response was, well, I think your building or this building is causing that. And sure enough, it was, in fact, the building. The relative humidity, I think, was in single digits or certainly in the low teens, which is what was causing the shrinking of those panels. Unfortunately, a lot of times when that occurs, the panels, even when it's the environment is restored to a 25 to 55% relative humidity, the panels may not actually come back to their original size. In some cases they may, and in other cases they may not. So let me have a show of hands. How many people that are dialed in today have had problems with architecture woodwork, either moving around or warping or shrinking? Boom, 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 boom. A lot of people, almost 50%, I think. A lot of this is, certainly you can design woodwork to be able to expand and contract without being restricted. And as I often tell design professionals, reveals are your friend. You can either design them into the project or they will magically appear. It's your choice. A lot of people, I don't know how many people that are listening have encountered the design professional that does not want any reveals. They want that solid 20-foot expanse of wood wall panels in that elevator lobby. And I always caution them about that, advising them that more than likely that's not going to work out the way they have envisioned it. I wanted to share with you a couple of contract terms that I became aware of just the last couple of days. I'll read them to you. One of them is from a general contractor, a very well-known national general contractor. And it says in here that the subcontractor to verify in writing 2 weeks prior to installation that the conditions and substrates are acceptable to install millwork. This shall include, but not be limited to, humidity, temperature, weather tight, etc. Subcontractor to provide written list of conditions that do not meet standards and review corrections made prior to installation. And that's a reasonable thing to have in there. But here's the catch-all. Once installation of millwork has begun, subcontractor is in acceptance of all field conditions and substrates where millwork is being installed. And I'll share one more with you before I ask you all a question. And this one is my favorite. And it's not in the contract documents, the project contract documents, but it's in a correspondence from the general contractor's project manager on this same project. It says the permanent equipment does not have humidification capabilities. And actually before that he said that the permanent equipment will be up and running and the space will be conditioned. However, he then says, we expect relative humidity lower than 25% during your installation time frame. The millwork should be designed to withstand the expected humidity levels in the building during service, which will typically be lower than 25% in the winter. I thought this was amazing, and he's probably absolutely right. It sounds like he's been there before, and he cites a 25% relative humidity number, which tells me that he's familiar with the architectural woodwork standards. But for him to say that the woodwork should be designed to withstand that is absurd. I don't know that he has the authority to do that, but I thought it was pretty interesting that he put it in there. How many people that are doing commercial work, I guess primarily, and maybe even residential work, put humidity readers, data loggers on site to track the level of relative humidity on the installation sites that they are either installing on or preparing to install on? Very, 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 very important. And I'll tell you why it's important, because it's very difficult for anybody to get to a job site and be told that the reason there's a gap in those panels or there's an alignment issue is because of relative humidity, unless you have the documentation to substantiate that statement. And the documentation is, in many cases, the data logger that you're going to have on site. And many data loggers will take readings. You can adjust it. You can take readings every hour. You could take readings every 15 minutes. Or you could take them every few hours. A lot of those are customizable. And this is a very bad picture here, but it does show you what's going on in here. And the humidity is that red line. So as you can see, the humidity, and we're looking at a space of time between 9:30 and 10:15, I think, on this graph. The relative humidity has gone from 30% to 45%, which is within the recommended range. I think I said on the last broadcast of this topic that I was involved in a presidential library project where the relative humidity was at 76% for an extended period of time, 3 weeks, I think it was. So what I did was I called for a QCP inspection because I wanted us to have documentation from a third party that the work was compliant before it started to react to the elevated humidity levels. And it did react. But I think that was good insurance. I don't know how many people have had projects where they had humidity problems, but it can be quite expensive if you are put in the position of having to go back and correct it or replace it. None of us want to do that. This is what's in the Architectural Woodwork Standards, this graphic. It's been in the quality standards, and it's also included in the Architectural Woodwork Standards, Edition 1 and Edition 2. And it shows that the recommended range of relative humidity for most of the country is 25 to 55%. That does change a bit in the Southwest, also in the Gulf states, up in New England, and in areas of Canada, it's a little bit different. So we have 70 to 50% in Canada and the Southwest, and we have 43 to 70 in the Northeast, and in the Gulf states, 43 to 70% as well. Many people say, well, what's going to happen if the environment is outside of that range? And I think the standards, at least the quality standard, says that variations outside of that range, and I think they gave a percentage of 20 or 30%, can cause extreme problems with the architectural woodwork. How many people have used the advisory that is contained in the Architectural Woodwork Standards? That is also a very great tool to use. How many people have actually been told to proceed with installation? The building's not enclosed, not acclimatized, and ask the general contractor to sign a waiver on your warranty. Just a point that I want to share with you, make sure if you have someone sign that letter that it is a principal of the contracting company, not the project manager. The project manager cannot bind the company. Only a principal can bind the company. I should have another story I could tell, but Greg, I think I'm going to ask you to jump in here.
Okay, so we'll begin here with, what causes this shrinkage? Is it the fact that the location had more moisture and then dried up, or what? Typically, I would say this is the fact that the moisture has gone away, and of course it's opened up. And of course, you'll notice also, you might note the amount of caulk that's already been applied to that gap. And here's another example of where you have veneer that is bubbling off of the door. Now, how much of that is due to the relative humidity in the building? That could be up for debate, but again, it's highly likely because I seriously doubt any of you woodworkers would have put up a door that had that bubbling in it when it started. So, who is responsible for relative humidity? When you look in the standard, it's rather clear that it's up to the general contractor and the owner to have the building conditioned before you start your installation. Unfortunately, we know that doesn't necessarily occur. and you're oftentimes forced to go ahead and go with the installation without it being. This is an example of what we all want to avoid. This is actually a project in Seattle, Washington, and we all know about the reputation of Seattle, Washington, how wet it is. And in this situation, the wall panels you see and the countertops are, the wall panels are particle board that has a clear finish on it. The countertops are MDF with a clear finish. The tarp you see in the foreground there was actually what they used to close the building up at night. And this is a situation where the woodworker warned the GC, and the GC said he wanted it in, start installing. So they did.
It's nice that they put the weight for the tarp on top of the mower. I like that.
Well, yes, I was actually did this inspection, and the wind was blowing through there very well, and had that tarp just flapping away. This is one of the many results. This is a wainscot, and you see the top rail of it has already swollen and opened up. Of course, you also notice it again. Painter didn't have any problem just going ahead and caulking that and getting his painting done. And this is present throughout the project. So how do you protect yourself? As Randy already discussed, the key recommendation from us is have a data logger. Track the relative humidity, because that's your best defense when it comes down to trying to explain the problem and trying to show, hey, I did what I was supposed to do, but this is the environment that it's in. These photographs are actually from taken at an airport in the north central United States. And as you can see, the ticket counter upstairs is 15.8% relative humidity with a 71.5 degrees. And baggage claim that was 59.5 degrees and a 7.5% relative humidity.
Yeah, just another word, if I can jump in here about data loggers. I think one of the first projects I was involved with when I came to AWI was the Brooklyn Court project in New York. And that project had more than its share of challenges and problems, and it had been through 3 general contractors. But they had 43 data loggers on that project for 8 courtrooms that were downloaded every day and put into a spreadsheet and tracked. And in addition to that, it's the only project I've ever seen where the general contractor had to install temporary systems. And when I was there, I think they had dehumidifiers all over the place. And they had it this clean up wherever they could put it, and dehumidifiers running to keep that relative humidity in that 25 to 55% range. And they had weekly progress meetings, and they looked at those spreadsheets with all of the data logger information very closely.
So the next few slides are going to be photographs from that airport. And our inspector actually did 2 inspections. The photograph on the left taken in October 2012, so it shows the typical joinery he was seeing. And then when he went back to the next inspection in December of 2012, you can see how the joints are starting to open up. This is another example of the same situation. Joinery was tight, and again, it's opened up. And I wanted to point out that this is another one. These panels actually were over the entrance door that all of the subs were using to bring in materials and going in and out. So the door was opening and closing constantly. And ultimately, the panel was right above the door and moved so much that it had failure of the edge banding. One thing I will point out, because of the fact that they were maintaining the data loggers and they reviewed the information with the GC and the architect and the building owner, they actually required that the HVAC unit for the building be redesigned to be able to maintain the required humidity levels. And here's another example. This is not the airport. This is on another project. These doors are actually interior doors, so they're not exposed to weather outside. It's actually in the interior. So they were having problems. They were tracking the humidity, and from January through March, as it says, humidity ran between 18 and 22%. They were also checking the moisture content of the doors, and the average 1 to 4%. As you can see, the doors are splitting. On the right, where you see the blue tape, the door is actually bowed that much from being flush. These next few slides are what we call the perfect storm of material, design, and location. So the material that was specified was raw wheat board. The design was to have a water-based transparent finish. Specifications calling for PVC edge banding. And then they decided to eliminate the edge banding. The location is a recreation facility, and the offices are actually located right next to the indoor pool. So in this situation, the woodworker actually was noting that the doors were bowing after they had been finished. That's where they even left their plant. And you can see here that the wheat board doesn't have an edge banding, so as we all know how MDF or wheat board work, that core is looser than the two outside surfaces, so it was just soaking up the finish. Most things that they put on it just kept soaking it up. And even though they were bowing, they were still told to go ahead and install them. So they installed them, and this is the result. And you see all the doors just continue to warp. And eventually what happened in this situation was that they finally acknowledged that the design probably was a mistake, and they're currently in the process of replacing all those doors with alternatives. How do you fix it? First thing is to anticipate. Review the plan of materials and note any areas that are likely water variance, the humidity, water features, instances like in the airport. And speaking of water features, we did have one project where they had actually designed a set of stairs to go over the top of a fountain. And all the stair treads were wood. And surprise, 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 they had all kinds of problems out of it. So you need to be aware of these things and do your best to try and address it in the early stages so that they're aware there's a problem and first you're putting them on the alert, but you're also trying to give them opportunities to redesign it. The next thing would be to mitigate. And with mitigating is designing for movement. First of all, you got to admit you can't stop it, but you can plan for it and in some cases control the direction. And when I talk about controlling the direction, what I mean is I usually refer people back to antique furniture that was made out of all solid wood, and how you take a solid top and you can lock down one edge of the solid top, but the other side you need to have slotted screw holes so that top can expand and move. And it's also similar to what Sandy was saying about reveals of your friend. If you know it's going to be moving, try and get those reveals, try and get permission to put in reveals so that even if it moves, it's not going to be as obvious. Third thing is to measure, as we said, track the humidity and temperature, but also make sure you keep an eye on what you're doing in your factory also. Because if your factory is not controlled and you have, or if it is controlled and you have the humidity right there, but you're moving it into an area that doesn't have control, you want to make sure you get that conditioning time in that location. Now, I know, again, that's difficult, but I know there are times that the general contractor is telling you, deliver it today and start installing it immediately, and you don't have that time, but you want to try your best to get that time to allow it to acclimate to the job site. And the fourth thing is, as we said again, document. Use RFIs saying, hey, it's not conditioned, are you sure you want me to continue with the track your humidity during the time? So the earlier it's brought to the attention of everybody, the better it's going to be. And you have the documentation. If it goes any further and they're starting to want to hold money against you, you've got something to help yourself possibly. So those are the things that we recommend.
I want to ask a question, Greg, if I can jump in here.
Sure.
How many people have had the general contractor ask them when humidity comes up as a topic, how many GCs have asked you if your plant is climate controlled? And if you could, just type in the chat box, what did they say when you told them that your plant was not climate controlled, for those of you that it isn't? Oh, there we go. How can you complain about the job site? I think you can complain about the job site.
Can you hear me now?
Yes, I can hear you now.
That was Mike's back. But it was a collaborated effort.
So what happened?
We typically, the contractor will say, well, how can you complain about our job site if your shop's not acclimated or climatized?
Right.
You know, and that's when we say, well, that's the idea of bringing it in and acclimating to the conditions where you're supposed to be. I tell them, don't worry about our factory, worry about your site. You know, what else you gonna do?
Well, that's true.
Have an air-conditioned shop down here. There is no way that's happening.
Yeah. I don't think too many people have that. There are a few, but not many. And you're right. If you allow the material to get on site and acclimate to whatever the environment is there, it will stabilize after a period of time. It will reach equilibrium with that environment, whether it's got more or less humidity than what your plant had. The thing to be cognizant about, I think, is that there's a different time frame for unfinished woodwork and pre-finished woodwork. Pre-finished woodwork is going to take longer to acclimate. I think the 8th edition quality standards said a week or more, which can be very tough given today's construction schedules, but just putting that out there.
One other thing I should have mentioned in measuring, I would strongly recommend that you also check the materials as they're coming in. Because I know during my time in the industry when I was running a company, we ran into a situation where our supplier was bringing us in material that was nowhere near the moisture content we had expected. And it took tracking it and letting them know we were tracking it and rejecting it before they finally got back in line and started bringing it in where it was supposed to be. But that's one thing to be aware of is, you know, I would check them just to make sure, because in those situations you can end up where you may be putting solid wood up against that has a high high moisture content up against sheet goods that has a low moisture content, and then those are battling themselves along with what you're putting, along with the humidity that's there on the site. So I do recommend that you do that.
How many people actually check the material that comes in when they have a moisture reader that they stick in that material?
We always do.
Yeah, I think it's just a good practice. I was a consultant on a project actually out in Las Vegas, and they were sourcing doors for a big high-rise casino project. And those doors, it turned out, had about a 32% moisture content, which you should be around 8 to 12%, maybe a little bit drier out there, but 30% was way over the limit.
Yeah, this is a project that where the humidity turned out to be very central, and in fact, the way it was handled ultimately allowed the entire project to be certified. The thing that was preventing that were these benches in a parking garage, and it was not until fairly late that we learned that there were a couple of doors to the outside that were pretty close to these benches. And it was the owner at first thought it was shoddy fabrication and then shoddy installation and so on, but the basic issue was that field seams opened way up in these benches. And at a certain point, the installer said, well, I am sure this is a result of humidity because of how open this space is to the outdoors. And having inspected the benches during fabrication and so forth, we thought he was probably right about that. So he volunteered to take some humidity readings. However, the owner did not trust him to do that. So they insisted on taking the humidity readings themselves. And the next slide there, Randy, has those readings, which I think you can probably see, and you will see that in the RH column, which is the percentage of relative humidity, there are consistent 15s, and they varied maybe to 15.5 and that sort of thing, but that is what it was. You can see the temperatures are not very high either, which would correlate with the low relative humidity. So once we saw these results, and the owner was pretty sure after they took these readings that because there was very little fluctuation and change in the humidity and temperature, that the conditions were not what was causing what appeared to be shoddy workmanship to them. They presented these to us fairly triumphantly, but when we pointed out that this was 10 percentage points below the lower limit in the standards, that pretty much ended the contention right there, and the woodworker got his entire project certified as a result.
You know, I've heard some QCP firms say that if the relative humidity is too high or low on their project, they can't get the project certified. How many people have heard that or believe that? Nobody.
Andy, can you hear me?
Yeah.
Hi, Wallace Fetzer here. How you doing?
Good, Wallace. How you doing?
Hey, yeah, I mean, that's kind of news to me. Nice to hear that we can get it certified as long as we're doing the right thing.
Yeah, and absolutely. And I think, to me, you know, getting somebody out there as soon as possible is really the goal, because you want that third party saying that you're compliant at that point in time. Then down the road, when you have issues or problems, you've got a document that says, well, no, this was, you know, everything was good here. So obviously something's not right here on you know, with the site or with the environment here.
I have another comment for you.
Sure.
Time for comments. When I heard your conversation just a minute ago about fluctuation in letting it acclimatize and let the wood move, I'm a bit concerned because we hold our relative humidity in our factory at about 35 to 40%.
Mm-hmm.
And if some people are stuck in a real humid environment, like at 45 to 55% all the time, and then they have to ship to a dry climate. If you ship from a 55 to a 25% humid area, your shrinkage may be so great in that 1 or 2 week period or 3 week period where it takes to acclimatize that it may blow your glue joints. You know, it may actually blow your product apart if you're going across 2 moisture zones, if you know what I'm saying. So we try to keep ours in the middle, so if we have to go high or we have to go low, we're safe either way.
I think that's a good practice. I don't know how many people actually check or monitor the relative humidity in their plants, but I think your target, you know, in that 40, 45, you know, 35 to 45 range is probably a very good target to try and maintain.
Yeah, and then when it goes below 25, we have to say something, or if it goes above 55. One other comment, we did a project at Fordham University, and they let the humidity get up to 65, 70, and we said, whatever you do, don't take the humidity below 40 now. I mean, there's $4 million of premium grade woodwork in your building. In the wintertime when it gets cold, if you turn on the heater, make sure you got the humidity on. Because if you go down below 2 moisture areas down to 25 from 70, it's going to blow apart. Yeah. And I think I'm right in that. Do you think that's the right advice to the building janitor?
Yeah, I mean, I don't know the particulars of the project, but obviously if there's not, you know, that design element built into it to allow it to expand and contract, then yeah, I think you're definitely going to see some effects with that kind of a range.
So what we were afraid of is that not that we had designed in the ability for it to expand and contract. What we were afraid of was glue failure.
Good point.
Because when they go up to 65 or 70 for 3 weeks, then they take it back below 40, it fails. Especially with the new glues, right? With formaldehyde, it wasn't so much a problem, but if you're not using a real strong glue, it can go.
Yeah, formaldehyde was a very rigid glue line, obviously, and a PBA has a lot of creep in it, so you're absolutely right. I was involved in, or I should say QCP was involved in a project in, I want to say it was Florida or Louisville, maybe, somewhere down there. And it was a performing arts center, and it was a lead project. So during construction and installation, they had the space sealed, and they were bringing in 100% outside air, which was, I think, 75% relative humidity. So there's another issue, and I don't know if that's still a requirement in lead projects or not. Maybe in interiors projects where there's other tenants in the building to try to manage that airspace, but that can be catastrophic to have a situation like that.
Yeah, let me tell you a quick one. We did the San Diego court. They have a 1-week flush out at the end.
Right.
And it was during the Santana winds, and they blew most of the woodwork. They took it down to 0 for a week. It was just crazy.
Oh my God!
They had a couple $100,000 of repair.
Yeah. Crazy stuff. Are there any other questions or comments from those of you that are with us? Yeah.
Randy, this is Mike Bell. Just wanted to point out that in the second edition of the AWS, there is a big change in the sense that exterior millwork standards were eliminated from the standards. And there was a lot of discussion about that, and what the conclusion of the committee was is that in a non-climatized environment, it's anybody's guess what woodwork is going to do. So there can be no standards for a non-climatized area. We're talking about areas that are climatized, but when they open it up to the open doors, to the outside, they're basically making that environment a non-climatized environment. And the way the standards read is that the non-climatized environment, that the standards will hold to the point of installation, but after installation, the standards no longer have a bearing on it because there's no control over what's going to happen to that woodwork. So even though technically the standards, if it's an interior product, it's put into interior, the standards do cover it, but if the climatization is relaxed or relieved, it becomes a non-climatized space, and I believe that the same thing as far as woodwork that's outside would govern what's going on inside in non-climatized situations. Just a thought.
Good point.
So that applies to woodwork in a situation where the woodwork subcontractor is being asked to install wood in a non-controlled environment.
Correct. Yes.
So this is Wallace again, Mike. We had a job that was a building over a river back in Washington, and we found all of a sudden our wood started to fail, and we found out that the janitor turned off all the humidity control and all the air conditioning on the weekends.
Yeah, that's an interesting point, Wallace. I know that GSA at one point had mandated all their federal courthouses, I don't know about their other properties, but to maintain their systems 24/7. I don't think they're doing that anymore, but it's a big issue when you've got $8 million in federal courthouse and maintaining that space.
Imagine you have an entablature 2 or 3 feet wide and an oval entablature that's maybe elliptical, 40 feet long and 25 feet wide, continuous wood, and then they do that. goes apart.
Yeah. A lot of people just don't get it.
Yeah.
You know, I saw it, you know, it's one of the first presentations, I think Louis Buckner did it. If you take a piece of red oak, you know, it could be a small piece, maybe 6 inches long, 3/4 inches square, it could be a little bit bigger. And you dip one end of it in dishwashing liquid and you blow in the other end, bubbles will actually come out of the end where the dishwashing liquid is. I thought that was pretty cool. But it demonstrates how porous wood is. I mean, it's really just a bundle of concentric drinking straws, if you will. So obviously there's a lot of room for moisture to get in and out of it.
My brother Paul always took that with him to the architect's demonstrations.
Yeah, that's a good one. Any other questions? Okay, I guess that's it. Thank you all for dialing in, and it looks like everybody stayed with us for the most part. Cameron, I think you have some closing comments to make.
Yep. Thank you. Thanks again, Randy, Wayne, and Greg, for delivering today's QCP Talk webinar. Thank you to our participant members as well for joining us, and I hope everyone found today's program to be informative and beneficial, and I hope to see everyone back online soon. Have a great rest of the day, everyone.
Thanks, Catherine.